In this video, we're going to talk about graphing linear functions. This is section 2.3 out of your book. So first, we've already talked about what is a linear function, but we're going to see it represented a couple of ways. This is function notation, f of x equals y mx plus b. That's the same as y equals mx plus b. So you guys are pretty familiar with that. Okay, so what these components are, right, is the m is our slope, okay, which a lot of times are referred to, I'm actually going to add a few other words here. So slope can be talked about as change in y over change in x, and that triangle symbol is the delta symbol, meaning the difference in. So the change in y over the change in x. It's also called rise over run, okay? And this slope part is what makes functions linear. So the fact that there is a constant change. So I'm actually going to put equals c for equals a constant, okay? All right, b is the y-intercept, which is the point at which the graph crosses the y-axis, okay? So defining a linear function is a function where y changes by a constant rate for every change in x. Okay? All right, so we're going to look at just a table. So we're trying to decide, is it linear? So we're going to look at the change in y compared to the change in x. So my change in y here is I'm subtracting 1. Change in y here is I'm also subtracting 1. And change in y here is I'm subtracting 2. So it doesn't really matter that these are different. What it matters is comparing the change in x to the change in y. So we're going to look at the change in the x's here. So my x's are, I am adding 2, and here I'm adding 4. So I can see that the first 2 points are changing by the same amount. So here's how I would write that. So from point 1 to 2, it's kind of a weird way to say it. The first row compared to the second row, slope is change in y over change in x. So for those, it is both -1 over +2. This one is also -1 over +2. The last one is -2 over +4, but -2/4 reduces to -1/2. So yes, we have a constant rate of change is what that's called. So yes, the slope is -1/2. Okay? All right, if we look at this table and compare the change in y compared to the change in x, here I have, I could say I'm adding 2, and then this one would be adding 4, and then adding 8. So because I'm adding a lot of different amounts every time, that's not really what's going on. I could write that though. But another pattern I see is these are just multiplying by 2 every time, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So I would say I'm multiplying by 2 is my constant pattern. And here I'm just going up by 1, right? So if it's multiplication or division, it is actually an exponential function. So this is not linear, it is exponential. And so addition or subtraction, so positive, negatives, adding, subtracting, that pattern makes it linear. If it's multiplication, it's exponential. Okay, we're going to graph each line. Okay, so if we are given a point and the slope, that is enough to be able to graph. So we're going to plot the point -1, -3, so left 1, down 3. And my slope is 5/2, so that means it has a rise of 5 and a run of 2. So my top number is always going to be the vertical change, bottom number is always the horizontal. So from this point I just graphed, I'm going to go up 5, 1, 2, 3, 4, 5, and over 2. All I need is 2 points to be able to draw a line. So once I have those 2 points, I'm going to connect them with a line, and then I'm going to add arrows on the end to show that that is going to continue in both directions forever. Okay, so if I'm given it in slope-intercept form, I have my y-intercept here is b, which is +3, so I'm going to put a point there on the y-axis at 3. And my slope is -2. So I'm going to write it as a fraction so that I get the rise and the run. If it's negative, the only difference is I'm going to go down. So I'm going to go down 2 and over 1. And the over part is always to the right. So just the negative changes up or down. So then connect my 2 points, and I have my line. Okay, so I kind of touched on this already, but this is our slope. Oh, sorry, read that wrong. Slope formula. So if the slope isn't given to me in an equation or just like specified like it was here, we can find the slope if we're given 2 points. So m is our letter that represents slope. We just subtract the y coordinates and subtract the x coordinates because slope is the change in y compared to the change in x. So I just need 2 points for that to happen. Point slope form, this one is really nice to use instead of slope intercept form because I don't necessarily need the y-intercept. It can be any point. So x1, y1, those are specific ordered pair on the line. And then m is still slope. Okay? All right, so let's take a look at some examples involving some of those. Okay, so here's another way we can graph. This is a standard form here. I'm actually going to kind of jump down here, you guys. Standard form is where I have something that looks like this. I have x and y on the same side of the equal sign with numbers in front and then equals a number on the right side. So this is called standard form. To graph, there's kind of a really handy method. We're going to graph by using intercepts. So now I'm going to do this example up above where I show you how to do that. So here is an equation in standard form. We want to graph using only intercepts. So intercepts happen when they're on one of the axes, and any point on an axis, one of the coordinates is going to be 0. So anything on the y-axis, the x-coordinate is 0. Anything on the x-axis, the y-coordinate is 0. So we're going to do what it says here. We're going to put in a value of 0 for one of the variables and solve for the other one. So for the y-intercept, we're going to put x equals 0. So we got 4 times 0 minus 2y equals 16. Well, this just goes away, right? 4 times 0 is just 0. So I'm really solving this. Negative 2y equals 16. So y has to be 8. So that means the y-intercept is 8. So on the y-axis, negative 8. So my y-axis, I'm going to go down and put a point at negative 8. So remember, I just need 2 points to create a line. So if I can also find the x-intercept, that gives me a second point. So this time, I'm going to put in 0 for y. And again, really all that does is that just gets rid of this term, and I'm just solving for x equals 16. So x is 4. So when we put in 0 for y, we got 4 for x. So 4, 0 is a point on this line, which is the x-intercept. And again, once we plot those 2 points, we just connect with a line and then put arrows on either side to show it continues forever. Okay, one other way we can graph by using intercepts, that's probably my favorite one because dealing with zeros is pretty easy, but we can also convert to slope intercept, which is y equals mx plus b, because we're very comfortable graphing that. So I'm going to show you that here on this first one. I am going to rewrite this one using slope intercept form. So all I need to do is get y by itself. So this one's pretty simple. I'm going to kind of go down here below you guys. I just need to get the x's to the other side. So I'm going to do the opposite. It's subtracting 4x, so we're going to add 4x to both sides. So I have y by itself, which is what I need for slope intercept form. I can't actually do this addition because they're not like terms. So I'm just going to write them next to each other, but I'm intentionally going to write the x's first so that it's mx plus b. So then my slope is 4 and my y-intercept is negative 1. Well, now that's pretty simple to graph. Negative 1 on the y-axis, and then my slope is 4 or 4 over 1. So I'm going to go up 4 and over 1 from that point. And so now I have 2 points and a line. Okay, this one I'm going to use intercepts that we just practiced, so I'm going to take turns plugging in 0. So I'm going to plug in 0 for x first. So 0 plus 3/4 y equals 6. Again, the 0 doesn't really change anything, so 3/4 y equals 6. To get rid of a fraction, we're going to multiply by its reciprocal, so 4/3, 4/3. So those will cancel, so I have y equals Think of that as 6 over 1, right? So I get 24 over 3. 24 divided by 3 is 8. So the x-intercept, or excuse me, the y-intercept is 8. So I got y equals 8 when x is 0. So 0, 8 is a point on this line. So 0, 8, plot that point. Now I'm going to switch. So I put 0 in for x. Now I'm going to put 0 in for y. So I have x plus 3/4 times 0 equals 6. Again, the 3/4 times 0, just going to cancel that y term. So I have x equals 6. So then this point is at 6, 0. It's the x-intercept. Okay, so I have 8 and 6 here on each axis. Again, connect. And we get our line. Okay. Couple last ones here, you guys. Special cases are where I only have one variable and it's equal to a number. So if it's x equals, I'm going to add this note up here. X equals, I'm just going to use c for a constant value. So if x equals c is a vertical line with undefined slope. We also have y equals a number, and it's actually always the same as our y-intercept, so I'm going to use b. So y equals b is a horizontal line with 0 slope. So I'm going to put m equals 0. Okay, so how we graph those, if it's x equals a number, I know it's a vertical line and it's going to cross through -2 on the x-axis. So think x equals -2, so find -2 on the x, and then you're just going to draw a vertical line through that value. So for these ones, I really only need 1 point. I don't really need 2 to be able to connect if I know it's horizontal or vertical. Y equals 4, so I'm going to find 4 on the y, and then I know it's horizontal, so it's got to go this direction through 4. And again, notice I'm using those arrows on either side. Okay, last example for this video, guys. What do slope and y-intercept represent contextually? So I added some labels here. You can do that in your notes packet as well. So let's say that this is graphing weight in grams over the number of weeks. Okay, so here's my equation that goes with this line. So I know that 2.6 is the slope and 4 is the y-intercept. But what do they mean with regards to these units? Okay, so remember, slope is always change in y compared to change in x. So if my slope is 2.6, it's 2.6 over 1. Okay, so another way to think about that is it's 2.6 change in y over 1 change in x. So I'm going to add on those units. So it's 2.6 grams for every 1 week. So my slope, and if it's positive, it's gaining that. If it's negative, it's decreasing by that. So we are going to say it is 2.6 pounds, grams, not pounds, sorry, grams gained per week. Okay, and again, anytime you have that division symbol, per is kind of an appropriate word to use there when we're comparing those two units. So grams per week should be the units we're comparing, the numbers we just got from the slope here. Y-intercept, I know from the equation, is 4. Okay, so 0, 4 is the y-intercept. So I can think about, okay, 0 is the x. So at 0 weeks, I have 4 grams. So that means whatever this is representing is 4 grams to start with. At the very beginning, before I start taking all this data, it's 4 grams to start. So 4 grams is the what we call initial value or amount. Okay? All right, that's it for 2.3. Thanks for watching.